Today we're going to be covering lesson 10.3, which is solving, so really kind of more traditional algebra. The last two lessons I feel like we were doing a lot of graphing, which sometimes kind of reminds me more of geometry, but we're going back to solving radical equations. So you can kind of see the examples down below here, and we've got 10 of them to kind of just go through and show you. But what I really want you to know is that today's lesson is really the opposite of lesson 9.3. In lesson 9.3, you were given problems like x squared is equal to 25. And so you had to get the x alone. And so what you did was you took the square root of both sides in order for this to cancel. Well, notice down here now you have the square root. So really, this is just going kind of backwards. So up here, once we got the x squared, so remember we had problems that looked like this. We had x minus 1 quantity squared is equal to, say, 16. So what we had to do was we had to take the square root of both sides and then we had to solve it. So notice the square root cancels the square. So now you're kind of the opposite. You have the square root. So how are you going to cancel the square root? So to cancel the square root, you would just square both sides. So if I square this, it cancels the square root, and I would just be left with x. But then I also have to square this side. So whatever you do to one side, you just have to do to the other. Now, 4 squared is just 16, and you're done. If you do notice, though, in this directions, there's a piece right here that says check your solution. You're gonna need to really watch this because in this lesson, we have what's called extraneous solutions. Now, you don't need to know how to spell that or anything like that, but what an extraneous solution is it's an answer that looks normal. It looks like it works, but when you test it, when you plug it back in and check, it fails. So when we plug 16 back in, we know that works because we already know what the square root of 16 is off the top of our head. So we know this one is okay and it works, but you're gonna see some extraneous solutions as we work through the paper. So I just want you to be aware of that, okay? So let's take a look at number 2. On number 2, I have to work to get this alone. So my whole goal here is to isolate this radical. So the first thing I'm gonna do is move the 3 to the other side. Now these will cancel and I have the radical isolated, and then on the left side I have an 11, and now this problem looks just like number 1. I've got the radical isolated so I can just square it. So if I square a square root, it cancels, and then 11 squared is 121. And now what I'm going to do is I'm going to grab my graphing calculator and I'm only going to type in the right side. So I'm going to type in square root of 121, and then I'm just going to move over to make sure that my bar doesn't continue to go, and then I'm going to do minus 3. And as long as this comes back to that number, I know I've done it correctly. So I'm all done. Okay? So as you can see on the paper here, they just kind of get maybe a little bit more complicated as you go. So at any time, if you want to pause these and give them a try, and then you can start the video up and kind of just see if you did them correctly, okay? So remember, on number 3 here, our goal is to get this alone. I cannot square it until that piece is all by itself. So the first thing I would want to do is move the 15. And so now I've got this cancels, and then I have, what, 9? And now I still have to get rid of this 3. So it's being multiplied. I'm going to divide it off, and so this will cancel, and I have the square root of a is equal to 3. And now I have isolated this square root, and so I'm going to do the opposite. I'm going to square it. Remember, we have to use its counter partner. So when I square this, it cancels, and then 3 squared is 9. And then I'm going to go back up to my original, and just make sure you type in the side that has the radical, only just replace it with your number, and now it needs to come out to be a negative 6. And it did. So this one is right as well. You are going to see an extraneous solution in a little bit. We just haven't had one yet. Number 4, this is a plus. We don't have any division in this lesson. So we're going to go minus 7. So I have 11 minus 7, which is 4. Now notice my radical is isolated. Even though I have this piece underneath, the radical itself is isolated. So I moved the 7 to the other side to get it alone. Once I have the radical isolated, I'm just going to go ahead and square both sides. By squaring, I've canceled the radical, and so I have s minus 3. And then when I square this, I have 16. And then now all I have to do is just solve this. So I move the 3 to the other side. So that'd be 19. And now let's test it. And I hope I get an 11 back. And I do. So I know I've done it right. Okay? So if you want to stop and pause and try any of these, you are more than welcome. Again, they're just kind of getting a little bit more complex. And then notice over here, we've got a radical on 2 sides. But this would be a perfect one if you would like to try it on your own and just, see what the answer comes out. So hopefully you pause it if needed. Otherwise, I'll go ahead and begin. I'm going to work. Remember, my goal is to isolate this part. So I got to move everything to the other side, kind of one by one. So that becomes an 18. And now I have to get this coefficient out of there. So I'll divide off the 3. Right? 6 times 3, I had to think about it for a minute. And then now that I have that isolated, I'm going to go ahead and square both sides. And then the square cancels the square root. And 6 squared is 36. And then now I just solve it like we would back in Algebra A, just a regular old algebra problem. So if I add those together, I get 42. And then I'm going to have to go 42 divided by 3. And I got 14. So let's see if that works. Now notice there's a lot to plug in here, but we can still do it. I have 3 times 14 minus 6 plus 2. And then I get 20. So I know I've done it right. So we still haven't seen an extraneous solution yet. But we always want to be careful and just kind of keep trying these because we just never know. So let's try this next one. Now this next one we haven't seen before. We have a radical on both sides. But do you notice that the radical is isolated? So if we were to try just looking at the left, if we were to try to get rid of this radical, we would need to square this. But whatever we do to one side, we just have to do to the other side. So we're going to square it. Well, that's okay. The square cancels the square root, and we just have d. The square cancels the square root, and so we have 5d minus 8. Well, that's not too bad. I can easily solve this. Now, there's a couple different ways in how you want to move things here, and if we were in class, I would probably pick one of you. But since I'm all alone, I guess this is probably what I would have done. So I would have a negative 4d. Now, be careful, that is a negative 8. You got to make sure that you're carrying the symbol with it. And then I'm going to divide by negative 4. And so I get d all alone equaling 2. Now, let's quick test it. On the left side, notice I have a variable on both sides. You see how there's a variable on both sides. So I'm going to have to type it into both sides of my calculator. So I have the square root of 2 on the left. And then on the right, I have 5 times 2 minus 8. Now you might be able to know the answer right there because what's 10 minus 8? So you know that actually they're the same. But if you want to just type them in your calculator, that's a good easy way too. So once again, we have a correct solution. Now I don't know where the extraneous ones are, but I know there's some on this page because I don't have any of the answer keys right in front of me here. So let's take a look at a couple more. Notice got a kind of a tricky scenario here. So again, if we were together, I would ask you, what do you think we should do here? And hopefully you're saying, well, we got to square them, right? Well, we can't really square with this subtraction. I can't really just go like this. If I try to do this, that actually creates a foiling situation because now I would have to FOIL this out. So I really don't want to do that because that's going to be a ton of work. What if I move this piece? What if I move this second piece right here to the other side? So what if I kind of pin them against each other? So if I add the square root to the other side, what happens over here is this cancels, and so I just have the square root of 4b minus 4, and then on this side I have 2b plus 4, like that. Now do you notice this is just like this other page? So now that they're pinned against each other, or they're isolated, I can go ahead and square both sides. So if I square this radical, I get 4b minus 4, and if I square this side, I get 2b plus 4. And then now again, you just have to kind of decide. I usually like to go towards the larger variable, so I would probably subtract the 2b. So that would give me 2b minus 4 is equal to 4, and then I would add the 4, just working to isolate this variable, and then I would divide off the 2. And then I need to check that. And it's always good to go back to the original. So I'm going to actually, even though I scribbled over top of this, I'm going to go back to the original problem. So I have 4 times 4, because I'm just replacing my variable with the number 4, minus 4. And then I just need to make sure I arrow over minus 2 times 4 plus 4. And then hopefully I get a 0 back. I do. So I know this is correct. So still haven't quite seen that extraneous solution yet, but we're making progress and we're going through our problems. All right. How about number 8? Number 8, look at this. We've got the square roots all alone, but we have a letter over here. We have a variable. Well, let's just see what happens. Let's square this because we know we have to get rid of it. And we're going to square this side. We can square a variable. So when we square the square root, it's going to cancel. And then we're going to square this side and we get an x squared. Think about that for a minute. What is that? That's a quadratic. If you try to take the square root, if you tell me, Mrs. Twig, take the square root of both sides to get rid of this, you realize you're just going to go back to the original. Okay? So you don't want to take the square root of both sides. What you have to do is you have to bring everything to one side. Now, I like my x squareds positive, so I would probably move the 4 over, and I would move the 3x over. So I would get 0 is equal to x squared plus 3x minus 4. Do you see how I put them all on one side? Now, you could factor. This is going back to your chapter 9. You could factor. You could go to Desmos and you could graph it. So there's a couple different ways to solve this one, okay? But since I'm already here, why don't I just try to factor it? X squared is x times x. And now with 4, I can either use 2 and 2 or I can use 1 and 4, but I need to get to a 3. So I'm sort of thinking 2 and 2 is not my best option because I can't get to a 3. So I'm going to use 4 and 1. Now this tells me my signs are going to alternate, which means that they're going to be different. And I want the plus 3. So I want a plus 4 with a minus 1. And then if I were to check my outer, I get a minus 1x. In my inner, I get a plus 4x, which is positive 3. So I know I've solved it right. And then what I do is I just set each of these equal to 0. So if I move the 4 over, I get a negative 4. And if I move the 1 over, I get a 1. Now, we have to be careful because this has 2 solutions. So let's quick check it. Let's plug this in. So I have 4 minus 3 times negative 4. Now, notice there's an x on this side. So I'm plugging the negative 4 in here as well. So when I hit enter on my calculator, it needs to equal a negative 4. And notice it's a positive 4. That means this is extraneous. So that is not a true solution. Even though this looked like a reasonable answer, it doesn't work. So there's where your extraneous comes in. Now let's try the 1. So I'm plugging 1 in on the left, and I'm plugging 1 in on the right. So when I hit enter, this needs to equal 1, and it does. So I know that is my only solution. Now let me show you in Desmos. Sorry, it's a little big here. Let me just kind of see if I can make it fit our screen a little. There we go. Okay, so in Desmos, we have, or in our problem, we have the square root of 4 minus, actually no, we want to graph the other one, sorry. We have x squared plus 3x minus 4. So do you notice in this one, notice it's going to give you the -4 and the +1. So this is another way to solve it. But if you're wondering, well then this looks like it works. Remember, we moved everything to one side. So if you notice, our original problem does not look like that. Do you see the original right here? This original does not look like this. That's after we've done some calculations. So if you want, I can go in and I can type this original in. So let me type the original in. So I'm just kind of showing you, so if you want to try these at home, because Desmos is a really fun, kind of tool to play around with. And so our next equation would just be x. Notice that is where they cross. Do you see how they only cross when x is 1? They do not cross when it's -4. So this is another way to kind of test it. So for instance, if you were to be looking at number 9, you can kind of see number 9 down here in the bottom, okay? Let's say you wanted to test it in the calculator or in Desmos. Remember, the graphing or the Desmos will not understand letter B, so you do have to type it in as an X, but that's okay. It's not a big deal. So notice how I've typed this in, and then the second one is just an X. Do you see in my Desmos here that they never cross? See how there's no crossing. So I can tell you right now that this problem, number 9, is probably a no solution. But let me show you how to do it by hand. Now, if you think you're going to use Desmos, that's okay too. The only problem with that is if you don't score high enough on your exit quiz, you are going to have to show these by hand. So it is helpful to know how to do these by hand, okay? So you're going to square both sides. So the square is going to cancel the square root. And so I'm in a similar situation as I was up here, where I have the x squared term with the bx and the constant. So I have the similar situation here. So what I'm going to do is I'm going to move both of these to the other side. So I have b squared, so I'm going to add the 2b to the other side. And I'm going to add the 1 to the other side. So there's my trinomial. Now, if we type this, or if we factor this, we get b times b. Now 1 is prime, so it's only 1 times 1. And this tells me my symbols are the same, and so when I look back, they're both plus. Now notice my parentheses are the same. So we call this a repeated root, which is okay. It just means that there's only 1. So you don't have to solve both. You just solve one of them. So you do 0 equals b plus 1, and then you simply solve it. And then you look at this as if it's your solution. And again, -1 doesn't look like that bad of a number. But if we plug it back into the original, so I'm plugging the -1 back in on the left, and when I hit enter, will it equal a -1 right here? And see how it doesn't, which means this fails. It's extraneous. That's why it's a no solution, okay? So again, just kind of something to keep in mind as you're working through these, that sometimes you get answers that look reasonable, but they may fail. So you really, really have to make sure that you're testing your solution. And then there was just one more on here if you want to give this one a try. This one again is kind of just got one little twist to it, but it's you know, if you want to skip it or if you feel comfortable, it's up to you. But I'm going to go ahead and go through it right now. So I'm going to move the 6 because remember, I can't square this. I cannot square this until I get this alone. So I have to work on isolating that, okay? So I have the square root now is equal to a -3. Now nothing really fancy here. I've got the square root alone, so let's just go ahead and square it. So we'll square both sides. So the square cancels the square root, and so we have 2x minus 1 is equal to 9. Then we'll go ahead and just solve this. So we'll move the 1 over, and then we'll divide off the 2, and we get a 5. So let's see if that works. So I'm typing in the 5, and then when I hit enter, will it equal this side? Will it equal the right side? Whoa, it doesn't. So again, this means it's extraneous, so it also must be a no solution. And let's just quick test check Desmos because it's so handy, especially, you know, I've got it right here on my screen. So I've got the square root of 2x minus 1 plus 6. Now notice in this one, if you look at this problem, do you see how it's a constant right there? So what I'm going to do is in the second equation, I'm just going to set it equal to 3. Okay, actually I think I might need to say y equals 3. Let me see if I need to also put equals y on that one. Okay, and there's the 3, and let me see if I can kind of zoom out here. So there you can see this top one, that's this one. Okay, so you've got this square root one, and then notice you have the 3. Do you see how they never cross? So our answer here, our answer of no solution is correct. So that concludes lesson 10.3.